Hello, everyone, and welcome to another episode of 10 Minutes to a Better Building. I'm your host, Tyler Kern. Thank you so much for joining us here for this podcast brought to you by Boland today. Now, on this episode of the podcast, we are diving into VRF, and we're going to tell you the ins and outs and talk about when VRF might be right for certain people and certain circumstances. And so joining me, luckily, we have an expert here today. His name is Jason Lawrence. He's the VRF technical specialist at Boland. Jason, welcome to the podcast. Thanks for joining us.
Hey Tyler, how are you?
I am well. How are you this morning?
Good. I'm glad to be here. And
Yeah, this is going to be a great episode, and I think this is a really great topic to dive in and discuss, because Jason, you have a lot of specialized knowledge in this area. So, Jason, while most of our regular listeners are probably familiar with VRF, there might be some who could use an introduction to the system. So, give us a brief rundown of what VRF is and how it works.
okay, yeah, most VRF, what it is it's heating and cooling equipment, and it's a split system. So we have a condenser outside, and then we have indoor units. We could have up to 50 indoor units, or we could have something as simple as a condenser with one indoor unit. And what's different from other heating and cooling equipment is it's a DX refrigeration system, but it has refrigerant in it, but the compressor is actually modulating variable capacity. Same thing with the fan motors. So we're able to match capacities in the building, match the loads. So there's multiple different types of indoor units. We have the ones that most people have probably seen that hang on your wall. It's just like a white long thing. It's got the little blade on it and very quiet. But and then some of them take the place of your ceiling diffuser in an office setting or something like that. And then there's ones that look like a standard split system air handler that you'd have in your house.
Excellent stuff. So Jason, some people, if you Google VRF, might see that that some people are saying that it's ductless. That's what that means. Is that always the case? And if not, I mean, maybe give us a brief explanation if possible.
Now, ductless is almost an improper term, but it's named after a lot of those units, like the wall mount that I talked about and the ceiling cassette. But there's a lot of ducted units as well that have air ducts on them. The difference being that we may have a smaller duct system on a VRF unit. It would maybe cover a smaller area because these are set up to more do zoning where you have your own control of the thermostat in each area. We like to call it a controller more than a thermostat, just because the controller communicates with the system and a thermostat merely just makes and breaks contacts. So I guess that would be the difference there. But yeah, we're able to control to different temperatures, kind of like a zoning system with individual units throughout the space. So you'll have a smaller duct system, if anything, maybe feeding one space generally.
So, Jason, maybe break down some of the benefits of employing a VRF system. Talk us through some of those benefits that someone might experience if this were the thing they decided to go with.
Okay, yeah. So if like a regular system, something like you have in your house, you have a setting on your thermostat, and let's say it's summertime and we're a couple degrees warmer than what you've set on your thermostat. Your unit comes on full crank, 100%, right? And it's running at 100% of its capacity. If it's a 3-ton unit, it's running 3 tons of cooling, all the way down to where it meets the set point, and then it turns off. And then it sets for a little while, and when the temperature comes back up, bang, it's on 100% again, and then it turns off. So it's similar to say uh, a car. The VRF system is able to match the load, right? So when we're at a stop and we have to start up in the beginning, then obviously we have to apply more energy in order to get everything running up to speed. But once we get to that speed, kind of like your car on the highway, once you reach the speed, you back off of the gas pedal a little bit and just kind of maintain a certain amount of input. And that's kind of what the VRF system is able to do. We want it to match the load. It stops so much of the slamming on and off. So it's very energy efficient that way. We're able to remove more humidity because we have a longer run time, and it just keeps people even temperatures throughout and comfort. It's also quiet, extremely quiet system. So you barely even know these things are running. Sometimes even the condensers outside, especially some of the smaller ones, people could walk by and wonder, if it's even working. Is the compressor running in that, or is that just the fan moving real slow? And so yeah, that's another real benefit, is that it's quiet. Another benefit is that they fit into small spaces. So a standard system, your unit might be large, and you might have large ductwork, and the builder has to allow a lot of space for that mechanical equipment to go. And you see things like bulkheads that are built around ductwork in your house and things like that aren't pleasing for people. So when when we have these systems, they're smaller indoor units, and we're just hiding a little bit of piping and wiring that runs to them. So we're able to put them in spaces, a lot of older buildings where you know you may not have space dedicated for a mechanical system, and now we can heat and cool without changing the aesthetics too much. So
So that sounds like a lot of pretty incredible upsides, right? Everyone is looking for ways to be more energy efficient and things along those lines. And so, are there downsides? So, what are some of the downsides? Because right now, I'm just thinking like this sounds like a no brainer for a lot of people, a lot of buildings, a lot of situations. So, what are some of the downsides that might sway someone against going with VRF?
well, okay, so I guess more than a downside, maybe I would call it, possible pitfalls or things to watch out for. So just like any system, there's places and applications where VRF applies, and then there are other places where maybe it won't do so well. But VRF is so if you have a system, say you had one of these larger systems where you had 40 or 50 indoor units on it, and you wanted to apply something like that, um, you could have almost 200 pounds of refrigerant in that system. So if you're feeding some smaller spaces with that, it's one big open refrigerant system. So if there's a leak or a sudden large leak, you could theoretically lose all of that refrigerant into a small space and possibly suffocate occupants. So there's ASHRAE 15, which is put in place to make sure that the system is not able to displace all of the air in the room in a certain amount of time. And there's calculations for that, but we won't necessarily get into all of that. So in a application like that, where you might be feeding a smaller space, maybe we just need to add a smaller condenser for that smaller space, or just work with more than one condenser and less indoor units to keep the system smaller. So that's just one thing that we have to watch out for when we apply VRF. And another thing to watch out for is, or another concern that people have, and I think it's kind of blown up to something that people find scary because they don't know. And it's it can be more of a complex system. So standard conventional HVAC equipment, there's a lot of things that are kind of standard and standardized. The thermostat wiring, the R, the W, the Y, those things might be the same from brand to brand. Whereas with VRF, there's a lot of things that don't apply from brand to brand. One brand may do their addressing completely different than another brand, and one brand might use a different communication wire, have different processes than another brand for evacuating or parts of the installation. So contractors out there have to work with more than one brand, and I'm lucky I get to focus on one. We like to think ours is the best, but it's harder for them, to keep track of everything. So it's really important that training takes place, and that we get people trained on it. Some of these manuals are 300 to 400 pages long, and that can be a little bit scary. But for the most part, there's so much of that doesn't apply to one application or another. It's just covering so much because there's so much diversity in what we can do.
Right. Now, I think that maybe some of those factors that you're mentioning there at the end, especially the length of the manuals and things along those lines, speak to the importance of contractor training. Right. So, talk us through the importance of that, and maybe some of the resources that exist in that realm.
So it's really important that the contractors get trained, and we see every day examples of when contractors are not trained, and we run into problems on jobs. And it could be something just as simple as selecting the wrong control wire. It wouldn't be that hard, or wouldn't be a problem if we just ran the right, everything else is done right, but we have a control wire that doesn't have a shield on it or something like that. And then we don't have communication through the whole system. And it can be days of labor to go back through and rip all that out. And then the extra material costs and things like that, where if we just knew, sometimes people are intimidated by that big manual, like I was talking about, and they don't want to go searching through there and read the whole manual before they start. Most of us, we get the piece of furniture from IKEA and we throw the directions away. We'd start putting it all together. Well, some of that happens, out in the field too. So it's good to have the background and at least know where to find the answers. And, we go over in our training class um, how to search through the manuals and, just search a keyword and find what you're looking for. And just in general, how to quickly find the information that we need. And it's it could be a more major thing than just replacing some wire too. I mean, there's we could have refrigerant piping or heights that are out of the limits and things like that that could have been caught had we known what to look for and how to use the software that we have that verifies that all this will work. So it could save a lot of time and money for contractors to just have invest a little bit of time in the training for sure.
And tell us about the resources that Boland has available for training in this area as well.
We have an awesome training center down. It just got updated to the newest, latest, greatest N generation of Mitsubishi City Multi equipment, and it's in Lanham, Maryland. We have condensers set there, air cooled condensers, and many different ductless units, as well as a couple of ducted units there connected with the controls and everything, so we can put our hands on it. We can do startups, we can troubleshoot. We do a portion of the class where we go in and maybe set some switches incorrectly or disconnect a wire or something to let the people figure out what's wrong. So yeah, it's a really a great resource for us. We have a classroom next door, and we do a classroom portion of it as well. So some hands-on and classroom training. So it's a real benefit. And if you take this training and you finish it, it's like 1 day online and 2 days in person. The 1 day online is really about 4 hours of video, so it doesn't have to take you a whole day. But you then become certified, and you, as a contractor, can submit your project for the or I can help you. Part of my job is to help you submit the project for the extended warranty, which means we go from 1 year compressor warranty to a 10-year compressor warranty, and 7 years on the parts to 10 years on the parts. So you get a lot of benefit out of that.
Wow, that's some incredible stuff, and the resources that Boland provides is obviously just top notch in this area. So, Jason, as we begin to wrap up this podcast today and take a look back at some of the things we discussed, do you have any final statements, any final thoughts or conclusions you'd like to make, just to wrap us up here today in our discussion about VRF?
Yeah, I just go over my role a little bit. I really like what I'm doing here, and I get to meet with contractors. So part of what we're offering, not just the training class, where we can go out and meet the contractors at our training center. I actually do site visits and meet them on site anytime that VRF is purchased. Train VRF, then I have a site meeting with those contractors. We can go over, review some of the things they've learned in the class. If they haven't learned anything in the class, I can give them a quick crash course, at least to make sure that they avoid the most common blunders that we have. So I think it's really great. You don't see that kind of product support throughout the industry, so it's really good that we offer that support, and it's there for contractors.
Excellent stuff. Jason Lawrence, VRF technical specialist at Boland. Jason, thank you so much for joining us here on 10 Minutes to a Better Building and breaking this all down for us.
Oh, you're welcome. Thanks for having me.
Absolutely. And everyone, thank you for tuning into this episode of 10 Minutes to a Better Building with Boland. We appreciate it very much. Of course, we have lots of episodes of the show, so go back and check out those previous episodes and stay tuned for upcoming episodes as well, where we'll talk to more thought leaders like Jason about their expertise and what they're doing in the world of making buildings better. So stay tuned for that. But for this episode, for my guest today, Jason Lawrence, I've been your host, Tyler Kern. Thanks for joining us.